we'll begin talking about some of the properties of the elements that we can infer from the periodic table. First of all, electrons and atoms organize into what are called shells. When a shell is full, additional electrons that we want to put into the atom occupy new shells at higher energies. On the far right of the periodic table, this column right here, which we'll learn later, are called the noble gases. The electrons have a particularly stable configuration. As a result, these elements don't tend to react with anything. And as elements, they exist as gases and as individual atoms. When we add atoms to one of these, when we add electrons to one of these, and move to the next element, those electrons go into higher shells, and those electrons are easily removed. There's a general tendency, so for instance in sodium, so neon is very stable, and sodium, on the other hand, there's one electron that is very easily removed. The tendency of the propensity of atoms to give up electrons has a lot to do with the properties. And generally, as we go across a row in the periodic table, go from left to right this way, atoms atoms are more and more electrons are more and more tightly bound as we go across. Now, there is a big division among all the elements having to do with the propensity to give up electrons. If the electrons are relatively easily lost, that gives the element what are called metallic properties. You may be familiar with metals. Metals are things that conduct heat, conduct electricity. They're malleable. That means they can be formed, bent into shapes rather than brittle is what that means. And they are, for the most part, solid. There's some exceptions. Mercury, which I'm circling here, is a liquid metal. So there's a division in the periodic table between the metals and the nonmetals. The metals tend to give, and having to do with the tendency to give up electrons. And generally, that division is indicated by this staircase diagonal that I'm drawing here. And everything in the periodic table to the left and downward are metals, having to do with how easily these elements give up electrons. And when I say that, we're going to discover we're always going to find ourselves saying, except for hydrogen. Hydrogen is a nonmetal, even though it's on that side of the periodic table. And then on the other side, the block up here, these are nonmetals. Okay, then there are, so this is an important division in the periodic table that you should note. There are some elements that close to this line that have some metallic properties and are sometimes classified as metals and sometimes as nonmetals, and more commonly they're just called metalloids. I'm indicating the metalloids now. All are elements that are on this line. Boron is considered a metalloid. Silicon, germanium, arsenic, antimony, tellurium, and the last two here are of very little importance, so you probably don't have to remember them, polonium and astatine. However, all the rest are ones that you should be able to know as metalloids. So from this you should see that that from the periodic table you can tell whether an element is a metal, a nonmetal, or a metalloid. And also you should note that by far the greatest majority of the elements are considered to be metals.